Why different ocean waters don't immediately mix. Water masses in the ocean can differ in several important ways, such as temperature, salinity, density, sediment content, or biological composition. When two water masses meet, these differences can create visible boundaries known as fronts. Similar to the way that cream swirls in coffee, rather than instantly becoming uniform, ocean waters require time and energy to mix. Density is the key factor. Oceanographers often describe seawater density as being controlled primarily by temperature. Cold water is denser than warm water. For example, tropical surface waters are warm and relatively light. Polar waters are cold and relatively heavy. Salinity also plays a major role. Saltier water is denser than fresher water. For example, the Atlantic Ocean is generally saltier than the Pacific, and water leaving the Mediterranean Sea is exceptionally salty and dense. When these waters meet, the denser water tends to sink beneath the lighter water, creating layers rather than immediately mixing. An ocean front is a transition zone between two water masses with different characteristics. Ocean fronts can range from a few meters wide to hundreds of miles across. Scientists study these fronts because of the way they influence weather patterns, ocean circulation, fisheries, nutrient transport, and marine biodiversity. Many fish species, seabirds, and marine mammals congregate near fronts because of nutrients and food that become concentrated there. One of the most widely shared examples online shows glacial runoff entering the Gulf of Alaska. The striking color difference comes from fine sediment carried by glaciers, difference in salinity, and the difference in temperature. These waters are already mixing, but the process is gradual enough that a visible boundary remains. For example, the Baltic Sea contains relatively fresh water due to large river input. The North Sea contains saltier Atlantic water. The salinity contrast there creates a density gradient that slows mixing and produces distinct water layers. Perhaps the most important fact is that the Earth's oceans are part of a single interconnected system. Scientists call this system thermohaline circulation. Thermo refers to temperature. Haline refers to salinity. This circulation transports water around the globe through a combination of surface currents and deep water flows. The process helps regulate the Earth's climate by redistributing heat and nutrients across the planet. Some water that sinks in the North Atlantic may take hundreds or even thousands of years to reappear somewhere else in the world's ocean. Studying ocean fronts helps scientists understand climate change, carbon storage in the oceans, marine ecosystems, storm formation, and long-term ocean circulation. These boundaries are not evidence that the oceans are disconnected. They're evidence that different water masses retain unique characteristics while participating in a larger global system. The next time you take an international flight, try looking down and examining the divide. Maybe show the person next to you and tell them.